Hi there, Algebra 2, 4.1, Quadratic Functions and Transformations. Objective to identify and graph quadratic functions. Parabola is a graph of a quadratic function. Quadratic function is an equation where the highest exponent of the variable, usually x, is a square, which means it's to the second power. Example, f of x equals a of x to the second plus by plus c. Vertex form, a function is f of x equals a, parenthesis x minus h to the second plus k, where a is not equal to 0. Axis of symmetry is a line that divides the parabola into mirror images. Vertex of a parabola is h, comma k, the intersection of a parabola and the axis of symmetry. Okay, the parent function of a quadratic function. The parent quadratic function is f of x equals x to the second. It is the parabola that is shown below. The axis of symmetry is x equals 0. The vertex is 0, 0. If you remember when we did absolute value, so we did f of x equals a absolute x minus h plus k. The parent function for that was a v that looked like this. That is basically the same thing as this U-shaped quadratic function. Alright. So, this is your parent function. Obviously, the biggest thing that we changed today is instead of absolute value, we're going to put parentheses and go squared. This number, and this number are still going to do the exact same things it did in absolute value. So, what is the graph of f of x equals 1/2 x to the second? If you remember from absolute value, what does the 1/2 mean? Well, 1/2 means it is a compression because it is less than 1 but greater than 0. Alright, so we have f of x equals 1/2 x to the second. Alright, we're going to make a chart based off that. We're going to go -2, -1, 0, 1, and 2 for my f of x. Okay, so we're going to try to solve that. Okay. And I would write this down because I'm going to have to make it where you can't see this while I graph these. Alright, so -2 goes in there. -2 squared is going to give me 4. 4 times 1/2 is going to give me 2. -1 squared is going to be 1, because you're going to have -1 in parentheses because that's what x is squared. So you get 1. 1 times 1/2 is 1/2. 0 goes in there, you're going to get 0, and then 0 times 1/2 is still 0. 1 is going to be 1, 1 times 1/2 is going to be 1/2. Not 1 and 1/2, it is 1 times 1/2. Alright, 2 squared is going to give me 4, so then 4 times 1/2 is going to give me 2. Okay? That is that one. Now, I'm going to solve the other one in a different color. So when I go graph it, I know something. Once again, we have f of x equals -1/3. What does that negative tell us? Well, what the negative is going to tell us is the fact that it's probably going to open upside down. The 1/3 is going to tell me that it is probably compressed because it's between 0 and 1 there. Okay, so I'm going to multiply, do the -2, -2, -1, 0, 1, 2 again. When I put in -2 there, I'm going to get 4, -4/3. So I'm going to get -4 times -1/3, which will give me that. -1 goes in there, it's going to come out as +1, so I'm going to get -1/3. 0 goes in there, 0 times 1/3 is going to give me 0. 1 is going to give me 1, 1 times 1/3 is going to, -1/3 is going to give me -1/3. 2 goes in there, you're going to get 4, 4 times -1/3 is going to give me -4/3. And there I have both of them. Okay, what can you say about the graph of the function f of x equals a of x to the second if a is a negative number? Explain. Well, we just talked about that. If a is a negative number, it is going to open upside down. And we're going to see that right here in a second. Alright, so we're going to start out with a red one. Our first point was -2, 2, so 1, 2, up 2. Okay, you're going to have -1/2. So there's my -1, 1/2, 0, 0, 1, 1/2, 2. It'll look like that. Okay. The blue was -2/3, or -2, and it was 4/3. It'll look like that. The next one was -1, 1/3. And I can reflect over this because this is my axis of symmetry is going to go right down through here. So my points over here have to mirror over here. So it looks like that. Okay? That's what your two lines should look like. Now your two, one saying lines, probably. Alright, back to the board. Reflection, stretch, compression. Okay, so reflection, we talked about this. If it's going to reflect, you're going to have a negative. For example, if it's going upwards, you're reflecting across the x-axis right now, which right now, if it's positive, it's going to go up. If it's going to negative, it's going to go the opposite way there. Now, obviously, if we shift it a different direction, it will change that a little bit, and your axis of symmetry will probably be the opposite. Or it will be different. Okay? We went on to stretch. We didn't really talk about a stretch because both of our problems were not stretches. But a stretch is going to be a is greater than 1, which means that it's going to get bigger and bigger and bigger and bigger. It's going to get tall. If I pull someone like myself out, I will get skinnier and taller. If it is a compression, which means that your number is greater than 0 but less than 1, we are compressing it. We're making it shorter. So if I push on somewhere or something or someone, it has to get wider because somewhere it has to go with all that extra space. Okay? Graph of y equals a of x and y minus a of x are a reflection of each other across the x-axis. Increasing a stretch the vertical graph vertically and narrows if it is horizontal. We kind of talked about. Now we have maximum and minimums. With a parabola, even absolute value, you always had a maximum or you have a minimum. If it opens upside or going upwards, I would say that you are going to have a minimum because we know this is going to be the smallest number you ever get. But obviously it's going to get bigger and bigger and bigger as it goes higher. Now, A maximum is going to be when it opens upside down, in which case you're going to hit this point, and this is going to be the highest point you can ever reach. Okay, I guess we're going to the next slide. Graphing translations of f of x equals x to the second. Okay, we are going to do the charts here. Now, if you remember your absolute value, this might be really, really easy. Okay, if I was looking at this equation, what number am I subbing in for? K. If you recall from absolute value, that is going to tell me it is up 3. So up 3 is what we're looking for. So deal that, so I did the translation of what happened there. Now, g of x equals x to the second plus 3. So we're going to get -2, -1. I'm going to make the chart because we're still not probably at that point. All right. So we put in -2, we get 4, we get 7. We put in 1, we're going to get 1, so we get 4. We plug in 0, we're going to get 3. We're going to plug in 1, we're going to get 4. Plug in 2, we should get 7 again. Okay, I'm going to do the last one too while I'm at it. What do we think is taking place here? Well, what part are we adding in here? We're going +1. If you've ever noticed with +1 or pluses in this, you go to the left. So on this one, we're going to go to the left 1. Okay. H of x is going to be x squared plus 3. -2, -1, 0, 1, 2. Alright, so if I plug this in, and this is in parentheses, and I put it in there wrong. Alright, if I plug in, and this is out here, alright, maybe. If I plug in -2, I get -1. This -1 is going to be where the parentheses went, so the only thing squared is going to be this 1, which is going to give me -1. Okay? I'm going to plug in 1. I'm going to get 0. 0 squared is still going to give me 0. 0 goes in there, I'm going to get 1. 1 times 1 is 1. 2 goes in there. You get 3, or we got to plug in 1, so we get 2, which is 4, and we plug in 2, which is going to get me 3. 3 squared is 9. Okay, now we are going to graph these. Okay, so get rid of these from last time. Okay, I'm going to do the bottom one first because I got red in my hand. Okay, so I had -2, -1. That's wrong. That should have been a positive one. I was right there. Alright, so that should have been a positive one, my bad. So this should be -2, 1. It should be 0 or -1, 0. And then it should be 0, 1, and then it should be 1, 4, 2, 2, 9. Okay, our axis of symmetry is right here, because it's got to go through the vertex. Okay, so that means I had to go 1, 2, 1, 2. I had to go over 3 here. 1, 2, 3. Okay, so it should look like that. Now we said it was going to go left 1. Did it go left 1? Yes. Did anything else probably change? No. Okay, now let's do the first one, the original one, where we're to up 3. 1, 2, 3. Okay, we had -1 was 4. We had +1 was 4. And then we had -2 was 7. We have that. Now, the only thing we did with that is we shifted it up 3. Okay, this is vertex form. This is what we've already been working with. So, should not be anything new there. Like I've been trying to emphasize to you, the H, if it is plus, it is going to go to the left, which is the opposite. You got to think of what's in the parentheses. You're going to do the opposite of what you should typically do. You think plus, you go to the right. Alright, so you have f of x equals a to the second, parenthesis x plus h to the second plus k. So, with that being said, okay, there's that vertex form. I'll leave it up there. Alright, interpret this. Vertex form for y equals 3x minus 4 to the second minus 2. What is the vertex? First off, let's find the vertex. Alright. My y value is going to change based off of what is k? Well, it's minus 2. So my y value is going to be minus 2. Okay? This is a minus, so it's going to go to the right, which means it'll be a positive 4, because if I put in a 4 here, I'm going to add it. Okay? So that is my vertex. Okay? If it is inside there and it is a negative number, it becomes, there, you go to the right 4. So I have to go to the right 4, which means it's going to be a positive 4. Alright, the axis of symmetry. Well, the axis is going to go through the point in which this is at. Okay, so my axis of symmetry is going to go through my x, the x coordinate on my vertex. So my axis of symmetry is going to be x equals 4. Okay, is this going to be a maximum or a minimum value? Well, is it going to open upwards or downwards? Well, is it a negative number? It is a positive number, which means that it's going to open upward, which means you're probably going to have a minimum. Okay? At this point, so we've got the first 3 things. Now we need to find the domain in range. So, if we had to draw this just roughly, okay, we know that our vertex is going to be right here, and it is going to go upwards like this. Oh, wrong way. Okay. So we know it's going to be looks something like this, right? What is going to be my domain, which is my x values? My x values cannot go any lower than -2, right? So my domain is x has got to be greater than or equal to -2. our range. It's going to go on and on in both directions forever. All real numbers. That is my range for this one. Okay, on the next one. You have to do the same thing. What are the vertex and what is axis of symmetry? Okay. We have a -2, which should not change anything besides it is going to open up downward. You have a +1, which means you're going to go left 1. You are going to be up 4. So this is going to tell me my value, the K is. So it's going to be 4. And we're going to be to the right, or to the left 1. So there's my vertex. All right. Axis of symmetry is going to be, well, where is my vertex at on the x-axis? Well, it's going to be a -1, so x is going to equal -1 for my axis. Minimum or maximum, it's opening upside down. It's going to be a maximum. Okay, I would just kind of sketch out a quick graph here. You might be able to figure it out based off the information. There's my deal. So, domain. Range. Range is all real numbers because you're going to keep going on your y values both ways. My x value has got to be less than or equal to 4. That is all you have to do on that. Alright, translations of a parabola. Obviously, if that h changes, this one would be would be -2. So you're moving 2 units that way. Okay, if you're doing vertical, I should have switched those 2 pictures around. So those 2 and the last 2 should be switched around. You should just move it up 2 is what's taking place. So it would be +2 instead of k. And then the other one would be moving it as a horizontal and a vertical change. Okay, what is the graph of -2x minus 1 squared plus 3? Okay, what are the steps transforming the graph of x of 2 to this? Alright, before I move you, I'm going to do the bottom one first. And I'll do the one graphing one with this. Okay, so the first one, you're going to be stretched by 2, right? Because of the fact that it is a positive, so you're not going to reflect across the x-axis. You are above 1, so it has to be a stretch. So stretch 2. You're going to go to the left 2 because you have a positive 2 in your parentheses, and you're going to be down -5. Alright, now the nice part about doing that one first is the fact that now I basically can do the same thing to the other equation. Okay? So, we have negative -1, 3, so -1 means I go to the right one, and it says +3, so I'm going to go up 1, 2, 3. That is going to be my vertex. Alright? now I am going to be opening upside down. Trying to think how this adjusts. And I think the first time it should be like rise over run, and then it's just going to, so I'd be, since it's 2, I'm over, actually, it'd be a stretch, not a compression. So it'd be up 2 over 1, up 2 over 1. So I'd have something like this going on. I think the first dot you can do using your rise and your run and put them there, and then the rest you just go. Obviously the negative made it open upside down. Okay, now on this one, what quadratic function models this? Well, if I do freeze this, it would then, I would make my point probably about here. Okay, so I moved to the left 3. Okay. I moved up 7. I moved to the right 3, my bad. Okay, now what is the deal? It's about 1, 3. And it would have to be negative. So that would be my equation for this. The 3 shows me I went to the right 3, up 7, and that shows me pretty well my rise and my run on the first points that would take place, or first place it would cross. Homework has been changed, so don't worry about that. I will have it on Google Classroom in general.